is 2020 AMC 10A problem number 15. A positive integer divisor of 12 factorial is chosen at random. The probability that the divisor is chosen is a perfect square can be expressed as m over n where m and n are relatively prime positive integers. What is m plus n? A 3, B 5, C 12, D 18, E 23. So the key to this problem is finding a prime factorization of 12 factorial. After that, it isn't all that difficult. So the key here, obviously you could do this tediously by testing and adding up every single power and eventually finding the prime factorization of 12 factorial. But when you're doing the AMC, you obviously want to conserve time. So I'm going to show you a method that works with a theorem called Legendre's theorem that is much more efficient and much quicker to do. So all that we need to do here is this theorem states that if you have a factorial, let's say n factorial, and let's say you want to find how many factors of a prime number x are in n factorial. So what we do is we take the floor of n factorial over x, then we add the floor of n factorial over x squared, then we add the floor of n factorial over x cubed, and so on and so on and so on, until n factorial over x cubed becomes less than 1, where everything else would just become 0, so it's insignificant. So we can do this pretty easily with 12, since it's not that large of a number. So first we can do it with 2. So here we have n equals 12, and we have x equals 2. So you have 12 over 2 plus 12 over 4, or actually, I forgot to add the floor function. Oh, and as a clarification, the floor function is if you have a number, it's the nearest integer rounded down. So we have the floor of 12 over 2 plus the floor of 12 over 4 plus the floor of 12 over 8. And 16 is larger than 12, so that doesn't count. So the floor of 12 over 2 is 6, and then the floor of 12 over 4 is 3, the floor of 12 over 8 is 1, so this is 10, which means that there are 10 factors of 2 in 12 factorial. Now let's go on to x equals 3. So the floor of 12 over 3 plus the floor of 12 over 12 over 9. This would equal 4 plus 1, which means there are 5 factors of 3 in 12, since 27 over 12 is less than 1. Okay, now x equals 5. So we have the floor of 12 over 5, and 25 is already greater than 12, so this is just 2. And then we have x equals 7, so we just have the floor of 12 over 7, which is 1. And finally, we have x equals 11, and the floor of 12 over 11 is also 1. So now we can write our prime factorization. So for 2 we have 10, and for 3 we have 5. Okay, so we have the prime factorization. Have 1. So obviously the number of factors is just this plus 1, this plus 1. So this plus 1, 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 all multiplied together. So number of factors number of factors is 11 times 6 times 3 times 2 times 2. But we're not actually going to multiply this out because it's going to be part of a probability, which means we can hopefully cancel out some terms in the end. So now we just have to find the number of these factors that are squares. And this is pretty easy to do because our only conditions are that each of these factors have to have an even exponent. So this means it could be, for 2, it could be 2 to the 0, 2 squared, 2 to the power of 4, 2 to the power of 6, 2 to the power of 8, or 2 to the power of 10, leaving us with 1, 2, 3, 4, 5, 6 choices. For 3, it could be 3 to the power of 0, 3 to the power of 2, or 3 to the power of 4. For 5, it could be 5 to the power of 0, or 5 to the power of 2. And for 7 and 11, since they only have 1, they can only be to the power of 0. 11 to the power of 0. So here we have 6 for the 2's, 3 for the 3's, 2 for the 5's, and then 1 each for 7 and 11. So our probability is going to be this number, which is the cases where there are perfect square factors, over this number, which is all of the factors. So our probability, so final probability is 6 times 3 times 2 times 1 times 1 over 11 times 6 times 3 times 2 times 2. And thankfully we didn't calculate the sum earlier because, look, most of the terms cancel out. In fact, all we're left with in the numerator is 1 and the denominator is 22. So we have our m over n, 1 over 22. So now we just have to add them together, so 1 over 22. So 1 plus 22 is equal to 23. And 23 is answer choice E.